All right, good morning, good afternoon, or whatever it happens to be where you're at. This is Unit 7, Lesson 2. It's about Pythagorean triples and the converse of the Pythagorean theorem. Okay, let's take a look and see what we got. Definitions and such. This is what a Pythagorean triple is. It's simply any group of three positive integers, a, b, and c, that satisfy the Pythagorean theorem. In other words, c squared equals a squared plus b squared, and is known as a Pythagorean triple. Notice that c is always the largest of the three integers. So what you got to do is whenever they give you something, if they want to know if it's a Pythagorean triple, put it into the equation. And it is very important for both of these things to do it this way. Okay? If you put it in and they come up equal, then it is a Pythagorean triple. Okay? Example 1. They want us to determine if 3, 4, and 5 constitute a Pythagorean triple. Okay, so what we're saying is 5 squared, which is the longest one, is that equal, greater than, or less than 3 squared plus 4 squared? Okay, so we square this out, we get 25. We're still looking to see what the relationship is between 9 plus 16. Do the arithmetic here, we get 25 is equal to 25. So this means that these 3, 4, and 5 is a Pythagorean triple. Okay, so our result here would be, yes, it is a triple. Okay, let's look at example 2. This time they gave us a triangle that they said it has sides of 4, 5, and 7. They want to know, can that be a Pythagorean triple? Okay, so we put it in here. The longest one is 7, so it goes over here for C. So 7 squared is what relationship to 4 squared plus 5 squared? So this gives us 49 is what relationship to 16 plus 25? 49 is not equal to 41, so no, this is not a Pythagorean triple. Okay? All right. Definitions and things again. Okay, so we recall that the Pythagorean theorem simply states that in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Okay? So that's what we got. The converse of this states it in the opposite direction. So if in a triangle the square of one side is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. So basically what this is saying is either the converse or the original statement, this is always going on. The difference is up here we knew it was a right triangle, so we knew that that relationship was true. Down here we're saying that it is a right triangle because that relationship is true. Okay? Alright, so first thing they want us to do in example 3 is see if this triangle is a right triangle. So here we go. And in fact, since they're all integers, if they are, then this means that this is a Pythagorean triple. Okay, so 25 squared is what relationship to 7 squared plus 24 squared? Okay, so that gives us 625 is what relationship to 49 plus 576. So 625 is equal to 625. So yes, it is a right triangle by the converse of the Pythagorean theorem. Okay? Notice also, like I said earlier, since those are integers and it is a right triangle, that makes that particular group of numbers a Pythagorean triple. Okay, this time they gave us a triangle with sides 111, 114, and 15 is a right triangle. So what we're going to do is put it in here. So 114 squared is what relationship to 111 squared plus 15 squared? So we have 12,996 is what relationship to 12,321 plus 25. So 12,996 is not equal to 12,546. So this is not a right triangle. Okay? All right. We can also use the Pythagorean triple, or Pythagorean theorem, excuse me. We can also use the Pythagorean theorem to tell us that what kind of triangle we have. Okay? A right triangle, of course, the two sides of the equation are equal. Okay? An acute triangle, notice that the c squared, or the largest side squared, is less than the a squared plus b squared. Okay, that gives it an acute triangle. And it's very important that you do these with the C on the left. Okay? Otherwise, you're going to get confused as to which way these inequalities are pointing. Okay? An obtuse triangle is just the opposite. So c squared is greater than a squared plus b squared if it's obtuse. Okay? So here's the kind of things they'll do here. So in these examples, the lengths of the three sides of the triangle are given. The first thing you always want to do is check and see if it's a triangle. If it's not, there's no point in continuing forward. But if it is, then you go ahead and continue forward. So once again, our test to see if something can be a triangle is we take the two smallest numbers, add those together, and see if they're greater than the third number. Okay? So in this case, this gives us 7 plus 6 is equal to 13, and that is greater than 8, so that's possible triangle. Okay? So let's put it together and see what we get. Longest side is 8, so it goes on the left. 8 squared is what relationship to 7 squared plus 6 squared? 64 is what relationship to 49 plus 36? So 64 is less than 85, so this means that it is an acute triangle. Okay, example 6 is the same type of thing. Find the two smallest sides, which this time it's these two. So 11 plus 5 is 16, which is less than 17. So this cannot be a triangle. Okay, example 7, we've got three lengths here. The two shortest ones are 40 and 9. So 40 plus 9 is equal to 49, which is greater than 41, so it can be a triangle. So what we're going to do is plug it into the Pythagorean theorem. So we have what? 41 squared, because that's the longest one, is what relationship to 9 squared plus 40 squared? So this gives us 1,681 is what relationship to 81 plus 1,600? That gives us an equal relationship because they're the same on both sides. So this is a right triangle. Notice that since they're integers again, this is also a Pythagorean triple in case you ever need to know. Okay, example 8. Two shortest sides are 7 and 10, so we add those together. 17 is greater than 16, so it is a triangle. Okay, put it into the Pythagorean theorem. So the longest side is 16, so 16 squared is what relationship to 7 squared plus 10 squared? 256 is what relationship to 49 plus 100? 256 is greater than 149, so this means that this is an obtuse triangle. Okay, see if there's one more. Nope, there's not. So we'll go back to here. That concludes the lesson on the Pythagorean triples and the use of the Pythagorean theorem to the converse of the Pythagorean theorem to determine if triangle or what kind of triangle you have that you've got for your exhibit. Thank you very much. See you later. Be sure you have any questions and get them to me. Goodbye.